All right. Can everyone hear me okay? Did you all have some good lunch? All right. Okay. So what I want to talk today about is the zero knowledge system that we are building at Ligero. How many of you have actually proved a zero knowledge proof in anything? How many of you would like to prove today, right now? All right, then come in front. Come in front. I'm going to tell you how to do it using our system. And it's okay if you don't want to come in front, also if you're shy, that's okay. All right, so before I explain my title, let's start with what we want to do at Ligero. This is our vision. Zero knowledge is a tool. What we want to do is build useful and usable privacy tools with zero cost. I know that sounds crazy, but let me try to convince you that that is possible. Let's ask actually this question: what if zero knowledge proof cost goes to zero? Well, you can prove quickly, you get privacy, and it's cheap. That sounds a little boring. Why should you care that the prover cost could go to zero? But before that, let me also, again, I don't want to use buzzwords as prover cost goes to zero. What do I mean by prover cost goes to zero? Oh, I really mean zero additional cost. It means that you can prove zero knowledge on your device, or if you're an organization, on your server. You don't need to go pick up a 4090 or rush for a 5090. You can prove it on your device. And I want to say this is really, if you haven't seen this philosophy is also is born in zero knowledge. This is the paper that started it all by three legends: Shafi Goldwasser, Silvio Micali, and Charlie Rakoff. I myself, I'm a professor at Georgetown University, and my grand advisor is Silvio Micali. If you have never heard any one of these authors, especially Shafi and Silvio, present zero knowledge, I'll say I'll be okay if you leave my talk and go to a YouTube video and watch them talk about zero knowledge. That's how I fell in love with zero knowledge. But really what I wanted to point out over here is that zero knowledge proof is not about zero knowledge. It is about zero additional knowledge. You do learn something, but the point is everything else in the world is kept private. It's a remarkable concept. All right, so just in that philosophy, what we really mean here is that we don't want the users to bear more cost to do zero knowledge proving. Okay, so why should you care about zero knowledge cost? Well, you heard actually Aztec founder Zach gave an amazing talk in the morning. It's about bridging Web 2 and Web 3. It can enable a lot more things. It'll give you limitless scalability through L2s. It can solve interop. And you can do arbitrary off-chain compute and get the verification on-chain. You can also get very off-chain private compute on-chain. So instead of talking about technical stuff, what I thought, I'll go do a demo of what you can do on our platform. So first, we have this sort of page, which I can tell you later how to find this page, and you can do it. It basically will tell you how fast your device can prove a Ligero proof. Now, this number for people who are in the space, it's about the number of constraints per second you can do. But if you want to understand the measure of this number, here is sort of just an interpretation. What really happened on my device right now, I proved Poseidon hashes at the rate of 20,000 hashes per second. Now, what can you do on our platform? This is really what we unveiled this week. So this is our platform, and it's open for anybody, and I'll give all the links later, so don't bother trying to copy this thing. You can create a project, and I'm going to just pick one of these over here. What you can do is On the browser, just drop a C or C++ code. You also can do Rust, and soon you can do other languages too. Whatever zero-knowledge application you want to develop, you just drop it here on the browser, hit compile, and you give inputs, and then you can run. So the entire workflow here is on the browser. You don't have to do any GitHub cloning, learn the dependencies, go buy a 4090, everything straight from your device. And I want to say that, well, if your phone is big enough, you could do this on your phone too. You don't need a laptop. And once you build some cool application, do come to our platform, do build cool applications, you can just deploy and it goes to our marketplace. Right now, it's all open, like, everyone, you can deploy, you can share it with your friends, share it with your parents, with your grandmother, like you've done a zero-knowledge proof. And, all they will have to do is go to the marketplace, click this and click. Just 2 clicks, and then they have generated a zero-knowledge proof on their device. How cool is that? All right, so let me get back. So this is what we can do. This is part of our vision. We want to make developing zero-knowledge proofs easy. And I want to say that what we have on our platform is still not easy. And I'll tell you a little bit more about it. So also to just give you a context of our benchmark, you saw about 20,000 Poseidon hashes per second. Now, this is, I just pulled up this table from one of Starkware's posts last year. And the first version of theirs, the Stone Prover, which was a Poseidon hash function on a 252-bit prime, they were able to generate about 50 hashes per second on a quad-core Intel i7 machine. And now they switched to 31 bits, and of course you get a lot of, just directly you get a 16x improvement moving from a 252 to 31. And of course, they did a lot of amazing work too, and now they can do about 500,000 hashes per second on that. And what you just saw on my device that I ran with the speed test, you can do about 20,000 of these hashes per second. On peak, it's like about 27,000 on a 254-bit prime. We haven't yet implemented the 30-bit prime, and I can tell you why. Because we are focusing on identity-related applications where you want the performance on these larger primes where you want to prove signatures, etc. So we're still keeping with this because for many of the applications, we need this. But I want to say that if we switch to a 30-bit prime, and even if we don't get 16x or even the 1000x they get, even with like 20x over this, that amounts to real-time Ethereum block proving. That's the range that they want. And you would be able to do this on the browser. So coming back, this is our vision. We have built useful zero-knowledge proofs, but we still want to build useful and usable privacy tools. So let me define what this is in my mind, what's useful and what's usable. So for me, useful, I think of what are privacy applications for individuals, privacy applications for organizations. Privacy for individuals is client-side proving. It's about identity. It's about sensitive information that you don't want to leave your device. It can be things like, ZK email, ZK TLS, verifiable credentials. Europe is moving into the digital ID. Everywhere now, you're not going to show your credentials. You're only going to prove that you have the necessary credentials. And in fact, they are also trying to standardize zero knowledge. Privacy for organizations, it's kind of common knowledge that to scale Ethereum, you are going to L2s. And for us, you can get a lightweight form of privacy using ZK validiums. And if you are in this modular chain thesis, ZK validiums can allow organizations to open L2s with very basic Web2 kind of privacy already using this. You can do other things, with enterprise asset tokenization, off-chain compute. You can imagine off-chain AI compute, etc. Privacy for organization can be enabled through ZK validiums. And I'll tell you more later. What's usable privacy? For me, it should have a standard toolchain. You don't want people to go and learn a new language. Otherwise, it's going to be hard to bring developers from other spaces who care about zero knowledge or privacy. It needs to be affordable. Well, nothing gets more affordable than using your own device. And a portable implementation. You should be able to run it on any device. And finally, I want to say that again, this is a difference which, if you don't want to care, you don't need to care. We are not just a snark, we are a ZK snark. And today, I want to say privacy in Web3 comes with a lot of trade-offs. There is trade-off in terms of compliance for enterprise, for regulated institutions. They cannot use the privacy tools Web3 is bringing because they cannot bring in compliance. There is a cost issue. For private information, I'm not going to send it to a prover network, or I'm not, like in many cases, do I need to purchase expensive hardware, hundreds of nodes, do I have to rent them on AWS? And usability. I mean, how hard is it to tool these, to put in my application? And finally, trust. This is what we trade off. Hey, if I can't do this privacy, I'll introduce a trusted intermediary that will, take care of my sensitive information. And modern ZK falls short. ZK snarks they require huge memory. I mean, anyone who has designed this, they know this. You want performance stuff, you need huge memory. Stark-based ZK, which almost most people use, they don't run client-side. And I'm saying yet because I saw in the program, they're going to talk about it. But they don't run client-side yet. And most ZKs are built only for verifiability. This is the difference between snarks and ZK snarks. And again, this is not about complaining about other systems, because most of the applications of ZK today are about verifiable compute. It's not about privacy. So they are not built for privacy applications. They can put it in. All of the systems they can put, but they are not the default option. And the ones that do, and we saw a lot of talks today, the ones that do offer privacy require specialized tool chains. And there are some reasons why they want to go for these things, but you got to learn a new language. It's not like things that you already are familiar with. And there is a Vitalik quote that's kind of relevant to this discussion, that he says, client-side proving hasn't reached, like ZK VMs haven't reached client-side proving because it's not fast enough for anything. And this is something that we want to challenge, and we are challenging with our platform. You can build applications that scale to billions of gates or constraints, if you understand what this number is, and run from your device because we are memory efficient. It might take a little longer on your mobile phone, but you can still run the entire computation. So I'm going to do quickly. This is going to be the only technical part of my talk. If you want to zone out, watch your phones, it's okay. But I'll just tell a little bit about the ZK behind our tech. We are not Starks, because most of you come and ask, which is, and again, I don't blame. I mean, they are really, it's a very good tech. Our zero knowledge is the only memory efficient hash-based system. And hash-based is important because that's why it runs fast. If you use public key primitives, they are thousands of orders of magnitude slower. In our system, the zero knowledge is default. And we are a ZK VM. This is important so that we enable easy tool chains for building zero knowledge. And finally, we focused on building a scalable and portable implementation. So we chose to code in web GPU because then most devices that have GPUs can scale our technology. And if we had done our system on CUDA and run on a server, it's going to run that much faster if people know the overhead of CUDA versus web GPUs. So what's the secret ingredient? We are hash-based, which makes us fast. There is a technical thing called code interleaving that allows us to parallelize without recursive composition. People who have built Starks and done this in production-ready systems, what they do is sharding and recursive composition. We can do sharding without recursive composition. And recursive composition is one of the heaviest parts of this computation. And we are memory efficient. But honestly, I mean, as much as I want to say these are the secret ingredient, there isn't a secret ingredient. That reference because my daughter is watching now Kung Fu Panda, so I had to, put it over here. The point I want to make is that a lot of these properties, at least theoretically, follows from something called MPC in the head. Come and ask me later and I'll tell you. Just a quick comparison here. CIRCOM, which kind of led the way in terms of doing this privacy-related applications, and there's so much work done there, but it's hard to put that on a device because the proving key is big. And now Aztec has, taken this effort to do client-side proving. We tried to benchmark their system on a browser, and again, please take these benchmarks with a grain of salt. I'm not trying to say that we are much, much faster or anything. We tried to benchmark their system on a MacBook M1 browser. We got their speed around 50 kilohertz. Now, on an M1, we are between 250 kilohertz and 1 megahertz. And this machine, what I have is like really, really fast. It's an M4 machine where we can go from 500 kilohertz to 6 megahertz. And that amounts to like 27 Poseidon hashes per second. I'll leave this tweet for now, and I'll come back to later. What I want to talk to you about is our roadmap, and this is really the last couple of slides that I want to talk about. So today what you can do on our platform is you can drag and drop C++ and Rust programs. You can build a zero-knowledge proof system. You can deploy it in our marketplace. What's coming up next, really, what I said is that, yes, this actually already simplifies the tool chain a lot, but it's still not plug and play. This is really what we want. We want a no-code version of our zero-knowledge system. It should be easy. You want an identity-related application, you just pick and choose, this is how I want my identity-related application, and bam, you can just put this gadget in any of your apps or browser, etc. So we want to solve identity by understanding this form factor to do this plug and play. That's privacy for individuals. Privacy for organizations through ZK Validiums. We want to not just provide EVM-compatible chains. Everyone wants EVM-compatible chains. But they also, to get the next generation of applications from Web 2 to Web 3, from enterprises to Web 3, you're going to need more off-chain compute. You need to provide database access or some off-chain AI compute or regulatory compliance. You want to check certain parameters regarding the accounts that you onboard on your system. And with our ZK, you can tool this easily. And the next phase, really, which I'm super excited about is, there's been a lot of work that's done into optimizing these circuits, and we want to benefit from this. We have almost already written a compiler from CIRCOM to our system, which means that all the beautiful work that's been done in CIRCOM, we will benefit from those optimized circuits. We also are going to do this with Noir and Cairo, where again, so many developers have put effort into doing amazing things. And we want to enable these applications to be in our system as API calls. Like if Noir has, oops, did I do something? It's okay, I can speak extempore. So if you have an API call, you can just have an API call to an optimized circuit in Noir and an optimized call for another circuit from CIRCOM. And we're also interested in, of course, doing AI compute. Just take an Onyx code, which is one of the formats to specify these models, just drag and drop onto your browser and be able to prove it. So stay tuned. Here is, if you want to take the QR code, this would help you run the speed test, but you'll also have the link to go to the platform. I know I'm running out of time. If you are an iOS user, you have to enable Web GPU. Soon it will be embedded. You wouldn't have to do it, but right now it's a developer feature. So here's just a quick screenshot of how you would have to, you can do this. And post your numbers on Twitter. I'll share our Twitter handle. Tell how fast your device does. I'll definitely repost and love it. Back to what we are doing. We want people to be able to build it anywhere, build in any language, and deploy it everywhere. ZK, anywhere, everywhere. Thanks.
Thanks so much for your enthusiastic presentation. Really appreciated you livening things up a bit around here.